You eat breakfast every morning. You have been told your entire life that breakfast is the most important meal of the day. Maybe you eat oatmeal with fruit. Maybe you have eggs and whole wheat toast. Maybe you blend a protein smoothie and call it clean eating. You feel disciplined. You feel like someone who is doing the right thing. And your body is silently routing every calorie from that breakfast directly into the fat depot that sits inside your abdominal cavity, wrapped around your liver, your kidneys, and your intestines. Not because you chose the wrong food, but because of when that food arrives in relation to a hormonal window you were never told existed. The timing collision that drives this is not random, it runs on a biological clock. And most people eating breakfast this morning are eating directly into it. This is not about calories. This is not about clean eating versus processed food. The mechanism that determines whether your breakfast builds lean tissue or packs visceral fat operates on a schedule that your meal timing either works with or works against. The difference between those two outcomes can be measured in nanomoles of insulin per liter of blood, and the mainstream breakfast conversation has chosen to ignore that measurement almost entirely. Here is what the research actually shows. A 2018 study published in Cell Metabolism by Satung and colleagues at the University of Alabama at Birmingham demonstrated that identical caloric intake, the exact same food, the exact same amounts, produced dramatically different metabolic outcomes depending solely on the time window in which those calories are even, not what was eaten, when it was eaten. The group eating in an early 6-hour window showed measurably lower insulin levels, better insulin sensitivity, and reduced visceral fat accumulation compared to the group eating in a late window. Same calories, different biological result. That single finding is the backbone of everything I'm going to walk you through. Before the hour-by-hour breakdown of what is happening inside your body from the moment your alarm goes off, I need to name the invisible villain. Not a food, not a macronutrient, a timing collision between two hormonal systems that are both doing exactly what they were designed to do, just not in a sequence that benefits you when breakfast enters the picture too early. The villain is the intersection of your cortisol awakening response and your morning insulin curve. If you have never heard those two systems described together in the context of fat storage, that is the precise gap this video fills. Every single morning, without exception, your adrenal glands fire a chemical signal the moment your brain crosses from sleep to waking consciousness. This is not the stress cortisol associated with anxiety, pressure, or a difficult week at work. This is a completely separate biological event called the cortisol awakening response. Within 30 to 45 minutes of opening your eyes, your cortisol concentration rises between 50 and 160% above its overnight baseline. Researchers in psychoneuroendocrinology have been measuring this response for decades. It is one of the most predictable hormonal events in human physiology. This cortisol spike serves a specific survival purpose. The human body spent hundreds of thousands of years waking up in physical environments that required immediate action. Moving, hunting, staying alert. Cortisol is the biological starting gun. It sharpens focus, raises blood pressure slightly, and does something that almost nobody in breakfast content ever explains. It orders your liver to start manufacturing glucose from your own stored materials. Amino acids from muscle tissue, glycerol from fat breakdown, and lactate from muscular activity all get converted into glucose through a series of enzymatic reactions called gluconeogenesis. Your liver begins producing glucose before you have eaten a single bite, because historically, food was not guaranteed to be sitting in the kitchen waiting for you. That manufactured glucose enters your bloodstream. Blood glucose rises, and when blood glucose rises, even modestly, your pancreas releases insulin to manage it. This is where the visceral fat story begins, because insulin is not just a blood sugar manager. Insulin is the master regulator of fat storage, and it does not affect all fat tissue equally. Here is the piece that almost nobody in mainstream nutrition explains correctly. Your body stores fat in two fundamentally different locations. Subcutaneous fat sits beneath the skin and is relatively metabolically inert. Visceral fat sits deep inside the abdominal cavity, surrounding your liver, your kidneys, your intestines, and your pancreas. These two fat types respond to insulin through different mechanisms, different receptor densities, and different sensitivity profiles. Visceral fat tissue has a dramatically higher concentration of glucocorticoid receptors compared to subcutaneous fat. That means visceral fat is specifically more responsive to the combination of cortisol and insulin than the fat on your hips, your thighs, or your arms. When cortisol and insulin are elevated simultaneously, which is exactly what happens every morning during the cortisol awakening response, the fat tissue that responds most aggressively to that hormonal signal is the visceral fat depot. Research published in Obesity Reviews by Björntorp and colleagues documented this specific receptor density asymmetry between visceral and subcutaneous fat, showing that visceral fat cells preferentially accumulate lipid in a high cortisol, high insulin environment in ways that subcutaneous fat does not. The fat does not accumulate randomly. It accumulates in the one location where the hormonal signal lands hardest, and that location is deep inside your abdomen. Now you are awake, cortisol is rising, gluconeogenesis has already pushed glucose into your bloodstream. Insulin is beginning to tick upward in response to that internally manufactured glucose. This sequence is happening to every adult in America this morning with no food involved at all. The critical question that determines your visceral fat outcome is what happens next. If you eat breakfast, any breakfast, regardless of how clean, how balanced, or how protein forward you were told to make it, you add an external glucose and insulin signal directly on top of an already active cortisol and insulin environment. You are not replacing the morning hormonal signal with a better one. You are stacking a second insulin wave on top of a first one that your own biology already generated before your fork touched the plate. The combined environment, cortisol still elevated, first insulin wave from gluconeogenesis, second insulin wave from food intake, creates the precise conditions under which visceral fat storage operates at maximum efficiency. According to data from the Centers for Disease Control and Prevention, approximately 40% of American adults have prediabetes or impaired fasting glucose. In that population, the insulin response to this double stacking event is not modest and brief. It is amplified and prolonged. 4 in 10 people are walking around with a metabolism that overreacts to this exact morning sequence. And the conventional breakfast advice, eat within 30 minutes of waking for metabolic activation, never skip breakfast, fuel your body before it burns muscle, was written as if that 40% does not exist. For anyone over 50, this problem compounds in a specific way. Insulin sensitivity declines measurably with each decade of adult life. A person at 55 generates a larger and longer insulin response to the same blood glucose level than the same person did at 35. The cortisol awakening response in people over 50 tends to peak faster and at a higher amplitude relative to overnight baseline, creating a more compressed and intense hormonal window in the early morning. Getting breakfast into that window at 55 is biochemically different from doing it at 35. The visceral fat storage signal is sharper. The insulin clearance takes longer, and the visceral fat depot, already expanded in the average American adult through years of this exact pattern, is primed to receive the signal efficiently. None of this is detectable by feel. You eat your oatmeal. You feel virtuous. You feel fueled. The hormonal program running in your liver and your abdominal fat tissue at that moment operates several layers below conscious awareness, directed by molecular signals. Your hunger levels, your energy readings, and your bathroom scale cannot detect until years of accumulation have already occurred. This is what makes visceral fat the most dangerous fat in the human body. Not just because of its documented association with cardiovascular disease, type 2 diabetes, and chronic systemic inflammation, which is well established across the literature, but because it grows silently in response to a hormonal environment most people were never told exists. The research term for what I just described is chrononutrition misalignment. The timing of food intake relative to circadian hormonal rhythms determines metabolic outcomes independent of caloric content. This is not a fringe hypothesis. The circadian biology behind this earned Jeffrey Hall, Michael Rosbash, and Michael Young the Nobel Prize in Physiology or Medicine in 2017. 2 consecutive Nobel Prizes in Physiology, 2016 for autophagy regulation, 2017 for circadian clock mechanisms, are connected to the same foundational biological system that your breakfast timing either respects or ignores. That is not a coincidence. That is the scientific community placing the highest available marker on the importance of these mechanisms. And the mainstream breakfast conversation has not caught up. In the next chapter, I'm going to walk you through what is happening inside your body hour by hour from the moment your alarm goes off. I'm going to show you exactly where a standard American breakfast lands in relation to your cortisol arc. Whether you eat at 6:30 or 8 in the morning, I'm going to show you the specific window, and it has a documented open and close time where food intake stops competing with your morning hormonal system and starts working alongside it. And I'm going to show you what is happening inside the visceral fat depot in real time during each of those phases, because the molecular story there is more specific and more actionable than anything the breakfast industry has ever put in front of you. Let me start the clock exactly where your body does. Not when your feet hit the floor, but the moment your eyes open. That is minute zero. That is when the cortisol awakening response begins its arc. Everything that follows operates on a precise biological schedule, and your breakfast timing lands somewhere on that schedule whether you know where or not. Minute 0 to minute 30. You are still in bed, possibly reaching for your phone. Your adrenal glands have already received the signal. Cortisol is climbing. Your liver has received the gluconeogenesis order. It is not waiting. The enzymatic machinery that converts amino acids and glycerol into glucose runs at its highest daily expression level in the early morning hours. A pattern confirmed across multiple circadian biology studies examining hepatic enzyme activity relative to the light-dark cycle. The glucose production line is already running before your coffee maker has had a chance to warm up. Blood glucose is rising slightly. If you are metabolically healthy, the rise is modest, perhaps 10 to 15 milligrams per deciliter above your overnight fasting baseline. If you have any degree of insulin resistance, which affects roughly 40% of American adults, according to Centers for Disease Control and Prevention data. That rise is larger, potentially 25 milligrams per deciliter or more, and it takes significantly longer to resolve. Your pancreas has already begun releasing a small pulse of insulin in response. The visceral fat depot has received the cortisol signal and is beginning to open. Minute 30 to minute 60. Cortisol is approaching its peak. This is the highest cortisol concentration your body will reach in any 24-hour cycle under normal conditions. The gluconeogenesis signal from cortisol is at maximum amplitude right now. Your liver is producing glucose at its fastest morning rate. Circulating insulin, while still relatively low by post-meal standards, is meaningfully higher than it was during your overnight fast. The visceral fat depot, with its dense concentration of glucocorticoid receptors at full sensitivity, is responding to both the cortisol signal and the insulin signal at the same time. Lipid uptake into visceral fat cells is elevated. The fat tissue inside your abdomen is in active receiving mode. If you drink black coffee right now, you are adding a pharmacological cortisol amplifier to a system already at its daily peak. Research by Lovallo and colleagues at the University of Oklahoma Health Sciences Center, published in Psychosomatic Medicine, documented that caffeine amplifies the cortisol response in habitual daily coffee drinkers, not just occasional consumers. The cortisol spike that was going to peak at a certain level now climbs further. More cortisol means more aggressive gluconeogenesis. More glucose means more insulin. More insulin means the visceral fat depot stays in active receiving mode longer than it would have if the cortisol arc had completed its natural trajectory undisturbed. But the coffee question, while genuinely important, is not the central problem in this video. The central problem is what comes next for most Americans, minute 60 to minute 90. If you eat breakfast anywhere in this window, the 6 to 7:30 in the morning slot that covers the majority of American breakfast habits based on dietary survey data from the National Health and Nutrition Examination Survey, you are placing a food-generated insulin wave inside the most hormonally loaded window of your entire day. The cortisol awakening response has not finished its arc. Your liver is still in gluconeogenic mode. Your visceral fat receptors are still at maximum cortisol sensitivity. And now, on top of the internally generated glucose and the first insulin pulse that followed it, your intestine is beginning to absorb external glucose from your meal. The pancreas responds with a second food-triggered insulin release. In a metabolically healthy 30-year-old, this second wave is manageable. In someone over 50, with even mild insulin resistance, the second insulin wave is larger, Visceral fat receptor sensitivity is heightened by the cortisol still circulating, and the combined hormonal environment pushes visceral fat storage into a mode that subcutaneous fat never enters. Your hips and thighs absorb some of the caloric load. Your abdominal visceral depot absorbs a disproportionate share, directed there by the hormonal address attached to the package. This is not theoretical. A 2019 study published in the International Journal of Obesity examined meal timing in middle-aged adults and found that early morning meals consumed during peak cortisol hours were associated with significantly greater increases in visceral adiposity over time compared to the same meals consumed later in the morning after cortisol had descended from its peak. The food was not different. The cortisol context was. Hour 2. The cortisol awakening response has begun its descent. The peak has passed. Your liver is beginning to slow its gluconeogenesis output as cortisol falls and the internal glucose production order loses urgency. If you had waited until this point to eat, until after the cortisol arc completed its natural rise and early descent, the visceral fat receptor sensitivity would have begun dropping. The gluconeogenesis-driven first insulin wave would have mostly cleared. Your next meal would arrive in a hormonal environment where the loading dock is no longer at maximum receiving capacity. The same food, the same macronutrients, the same caloric load would encounter a different molecular landscape inside your abdominal fat tissue, not because you did anything dramatically different, because the clock moved. Hour 2.5. For most metabolically healthy adults, the cortisol awakening response has substantially resolved by 90 to 120 minutes after waking. Cortisol is approaching its lower daytime baseline. Gluconeogenesis has slowed. Circulating insulin from the internal morning glucose pulse has largely cleared. The visceral fat depot is no longer in peak storage mode. This is the window. This is where the same breakfast you are going to eat at 6:30 produces a fundamentally different metabolic outcome at 8:30 or 9, not because the breakfast changed, because the hormonal address it gets delivered to has changed. That is the entire argument in its most precise form. Now I want to spend a moment on the mainstream betrayal here, because understanding why you were never told any of this matters as much as understanding the mechanism itself. The claim that breakfast is the most important meal of the day was not born from metabolic science. It was born from marketing. Specifically, it was popularized in the late 1800s and early 1900s by cereal manufacturers who needed a cultural framework that made morning consumption feel medically necessary. The historian Abigail Carroll documented this origin in her work on American food history, tracing how the phrase became embedded in nutritional messaging through a commercial campaign that preceded any meaningful scientific research into meal timing. That would be an interesting footnote if the science had eventually confirmed the claim. It did not. Chrononutrition research has been producing consistent findings for decades, with the first systematic studies linking meal timing to metabolic consequences appearing in peer-reviewed journals in the 1980s. The mechanism was available in the scientific literature long before any mainstream institution chose to communicate it. The reason that guidance never reached the public is not mysterious once you understand who funds nutritional research. Between 2011 and 2015, major food and beverage manufacturers were among the largest contributors to American nutritional science funding, according to a 2016 analysis published in the American Journal of Preventive Medicine by Kearns and colleagues. Companies with direct financial interest in promoting morning meal consumption were funding the science that was supposed to evaluate whether that timing was metabolically beneficial. The output was not a rigorous examination of meal timing. It was research asking what to eat for breakfast, not whether the timing of breakfast was driving the very problem the research claimed to solve. I ran this pattern on myself for years. I was eating breakfast at 7 in the morning, tracking protein grams, avoiding refined carbohydrates, doing everything the standard guidance prescribed. My waist circumference was not responding the way the effort should have produced. It was not until I read the original chronobiology papers, not the summaries, the actual studies, that I understood I had been solving the wrong variable. I was optimizing what I ate while ignoring when I ate relative to the hormonal clock running every morning before I touched a fork. Shifting the timing of my first meal relative to my cortisol arc produced changes in abdominal circumference within 6 weeks that months of macronutrient work had not. I'm not offering that as clinical evidence. Individual biology varies, and anyone on glucose-altering medication should not adjust meal timing without physician involvement. But the alignment between what I experienced and what the research describes is why I kept going deeper into this literature. What I want you to carry into the final chapter is this. Visceral fat is not primarily a calorie problem. It is a timing and hormonal context problem. The same calories arriving after your cortisol arc has completed produce a different visceral fat outcome than those same calories arriving at the peak cortisol and peak gluconeogenesis window. The fat cells inside your abdomen respond to the molecular instructions they receive. And the instructions they receive between 6 and 8 in the morning, for most American adults eating within the first hour of waking, are storage instructions. Not because the food is wrong, because the clock says store. In the final chapter, I am going to hand you the exact protocol that changes those instructions. 3 specific components, each with precise numbers. I'm going to show you what to do, when to do it, and by how much you need to shift each variable to move out of the peak visceral fat storage window and into the metabolic context where the same food produces a different outcome. And I am going to tell you the one mistake that invalidates all 3 components, the error that most people make within the first week of attempting this. Because knowing the mechanism is not the same as knowing where the implementation actually breaks down. Everything I walked you through in the previous 2 chapters was building toward one question. What do you actually do with this information? The mechanism is clear. The timing collision is documented. The visceral fat storage pathway is specific and measurable. Now the protocol. 3 components, each with an exact number. No vague suggestions, no general principles without calibration. The biology only becomes useful when it is translated into a daily structure precise enough to actually move the variables that matter. The protocol is called the ARC protocol. The name is intentional. Your cortisol awakening response follows an arc, a rise, a peak, and a descent. And the entire intervention is built around respecting that arc rather than running your morning directly into it. 3 components, A, R, and C. Each one addresses a specific failure point in the standard morning routine. The A stands for avoid the peak. No food and no caffeine for the first 90 minutes from the moment your eyes open. Not from when you get out of bed, not from when you start getting ready, from the moment of conscious waking, because the cortisol awakening response begins at the moment of arousal. For anyone over 50, the evidence supports extending this to 120 minutes. The reason is specific. The cortisol awakening response in people over 50 tends to peak faster and at a higher amplitude relative to overnight baseline, meaning the hormonal window is more compressed and more intense. Getting caffeine or food into that window at 55 costs more metabolically than the same mistake at 35. The 90-minute minimum applies to metabolically healthy adults. 120 minutes is the target for anyone whose fasting blood glucose, if they have ever measured it, reads above 95 milligrams per deciliter before eating, or anyone whose waist circumference exceeds the clinical visceral fat risk threshold defined by the National Institutes of Health, 35 inches for women, 40 inches for men. During this window, plain water is unrestricted. A quarter teaspoon of sea salt in 16 ounces of water maintains electrolyte balance without generating any insulin response. Sodium does not stimulate insulin secretion. Inadequate cellular hydration during the fasting period supports the lysosomal activity your cells depend on for clearing metabolic debris. What you are doing during this window is allowing the cortisol arc to complete its natural rise and begin its descent without caffeine amplification and without a food-driven insulin wave stacking on top of the gluconeogenesis-driven insulin wave your liver already generated. You are not extending your fast dramatically. You are protecting the morning hormonal window that already exists by default, the one your current routine is cutting short every day. The R stands for root your circadian clock. Within 10 minutes of opening your eyes, expose your eyes to natural light. 2 to 5 minutes of direct outdoor exposure is sufficient. If your schedule makes outdoor exposure impractical, position yourself at the brightest available window for 10 minutes. Morning light exposure activates the retinohypothalamic tract, the direct connection between your retina and the suprachiasmatic nucleus, the brain's master circadian clock, which calibrates the peripheral clocks in your liver, pancreas, and adrenal glands, including the hepatic clock that governs gluconeogenesis expression timing. This anchors your cortisol arc to a consistent daily starting point and sets the adenosine clearance rate for the day, substantially reducing the mid-morning neurochemical crash that behaviorally pushes people to eat earlier than their protocol calls for. Sachin Panda's lab at the Salk Institute documented in a 2020 Cell metabolism study that consistent daily light exposure combined with consistent meal timing produced substantially better metabolic outcomes than meal timing alone. The light sets the clock. The clock determines what each meal does when it arrives. The C stands for compose the opening meal correctly. When your eating window opens, at whatever time your full fasting protocol designates, your first meal should not lead with protein. This is where most people implementing this protocol get it immediately wrong, because every piece of nutrition guidance aimed at people over 50 correctly emphasizes protein for muscle preservation. That emphasis is biologically justified. Muscle protein synthesis efficiency declines with age, and leucine threshold for triggering muscle repair increases. You genuinely need more protein per meal after 50 than you did at 35. None of that is wrong. The timing sequence within the meal is where the error occurs. Leucine is the most potent known activator of mTOR, the mechanistic target of rapamycin, which is the cellular pathway that signals growth and simultaneously shuts down fat oxidizing and cellular repair activity. A protein-first meal delivers a sharp leucine spike that triggers mTOR activation at the precise moment when your fat oxidation is operating at its highest daily efficiency. You spent 90 to 120 minutes protecting that window. A protein-first meal closes it abruptly. The correct sequence is fiber and fat first, protein second. Open the meal with a minimum of 15 grams of fiber from whole food sources. Half an avocado provides roughly 7 grams. 2 tablespoons of chia seeds provide approximately 10 grams. A cup of leafy greens provides 2 to 3, or with a fat source such as 1 to 2 tablespoons of olive oil or whole nuts. Fiber and fat slow gastric emptying and blunt the rate of amino acid absorption from the protein that follows. The mTOR activation still occurs. You want it to. Protein synthesis and muscle maintenance require mTOR signaling, particularly after 50 when muscle loss accelerates. But when leucine absorption rises gradually rather than sharply, the fat oxidizing window completes more fully before the cellular repair operation shuts down. The protein target for the opening meal is 25 to 40 grams of high-quality protein consumed after the fiber or fat primer. A 2022 study published in the journal Nutrients examining meal composition sequencing in adults with insulin resistance found that leading meals with fiber and fat before protein produced meaningfully lower post-meal insulin peaks and better maintenance of fat oxidation rates compared to protein-first meals of identical caloric and macronutrient content. Same protein, same fat, same fiber, different order, different hormonal outcome. Now, the mistake that invalidates all three components, the mistake is conflating the end of the 90-minute avoidance window with the opening of the eating window. People who correctly delay their coffee to minute 91 and then immediately follow it with a protein shake or Greek yogurt have solved the cortisol problem and created an mTOR problem in the same motion. The 90-minute coffee delay and the eating window opening are two separate calibrations on different biological timelines. The coffee delay protects the cortisol arc. The eating window opening is governed by your full fasting protocol, whether that is 16, 18, or any other duration, and should happen at its designated time, not at the 90-minute mark, simply because that is when the coffee restriction lifts. In practical terms, if your full protocol calls for an 18-hour fast and your last meal was at 7 in the evening, your eating window opens at 1 in the afternoon regardless of when you had your delayed coffee. The 90-minute coffee delay and the eating window are not the same event on the same timeline. Treating them as identical is the structural error most people make within the first week of attempting this, because the brain interprets permission to have coffee as general permission for the eating window to open. They are not the same permission. The version of this mistake that most frequently derails implementation is the protein shake immediately after the delayed coffee. The logic feels disciplined. You waited, you timed your coffee correctly, now you need your protein to protect muscle. What it produces is a sharp mTOR spike at the precise moment when the combination of low insulin, elevated growth hormone from the extended fast, and active fat oxidation is at its daily peak. You interrupt the highest quality hormonal window of your day with the one molecular signal most effective at shutting it down. And you do it in the name of muscle preservation that would have been better served by keeping the eating window on its correct schedule. The IRC protocol does not require an extended fast, a new diet, or any supplementation. It requires 3 calibrations: a 90-minute avoidance window from waking, morning light within 10 minutes of opening your eyes, and a meal sequence that opens with 15 grams of fiber or a fat source before introducing 25 to 40 grams of protein. Those 3 adjustments, consistently applied across at least 5 days per week, the minimum effective consistency documented in Panda's circadian adherence data, move your first meal out of the peak, cortisol and gluconeogenesis window, and into the hormonal context where the same food produces a different visceral fat outcome. The reason most people never make this shift is not lack of motivation.